facts of the universe for real. About 1 billion years after the Big Bang, the stars were starting to shine. Now it is possible to make stars on Earth. Janet went to see how you do it, and why artificial stars might one day save the planet.
In this ordinary-looking warehouse in the heart of Oxfordshire, Andy Kirk makes a star every 15 minutes. Making stars takes a lot of power. Real stars are made by gravity squeezing clouds of hydrogen. In Oxfordshire, they use electricity to make an incredibly strong magnetic field to do the same thing. Normal stars like our Sun form when huge clouds of hydrogen collapse in on themselves. The immense heat and pressure in the core of the new star causes hydrogen atoms to smash together and make helium, releasing enough heat to make the star shine. It's called nuclear fusion, and it's what they're doing here at MAST. MAST stands for Million Amp Spherical Tokamak. 1 million amps of electricity, and tokamak is the Russian name for the chamber where fusion takes place. Andy, this is an amazing piece of kit. What actually happens here?
This is our star maker, and to date we've made 16,000 stars with it.
Why is it so important for you to recreate what goes on in the stars?
Nuclear fusion is the process which powers the Sun and all other stars. Our aim is to recreate those processes here on Earth, harness the energy that's produced, and therefore be able to satisfy mankind's need for electricity and other power generation for more than 1 million years. Let's go this way.
So Andy's dream is to harness star power to produce energy, without fossil fuels, without greenhouse gases, and with no significant nuclear waste. If it sounds too good to be true, it is. For the moment, this machine is strictly for research.
Shot 16923.
Stars are made from plasma, a state of matter beyond solid, liquid and gas, and found in fluorescent lights as well as stars. The 4-metre star-making chamber is filled with hydrogen plasma, which is heated until the atoms fuse. The challenge is to contain it. The plasma has to be kept away from the walls or it collapses. The MAST team is finding out how to keep their stars stable, so they replay each one in ultra-slow motion. At real speed, each star is born, burns and dies in half a second.
That is the closest you come to creating a star on Earth. The centre of that plasma is at a temperature of 20 million degrees centigrade.
Why does it have to be so incredibly hot?
You need the heat in order to cause the particles to fuse together. They only fuse if you can get them very, very close to each other. To do that, they have to be travelling incredibly quickly, which means that they need a very high temperature.
Does it behave in any way like our Sun?
It has many of the features of the Sun.
Wow, what did it do then?
That is one of our solar eruptions. It's an instability in the plasma when the plasma is saying, oh, I don't want to be in this state, and it erupts, throwing out particles very similar to what you see in solar flares. They're a little like young children in that they're very much full of energy and they don't really want to be told what to do. And when we tell them to do something they don't want to do, they tend to throw a tantrum.
Throws all its toys out of the pram.
That's a good analogy, yes.